Hello everyone, myself Karthika Priya from 3rd year BEC department. Now we are going to see about the CLT presentation based on PN junction diode in data science. Okay, we can see about the definition of a PN junction diode. The electrical conductivity of a semiconductor materials is a between that of a conductor such as metallic copper and that of an insulator such as glass. Its resistivity decreases as the temperature rises, whereas metals have the reverse effect. By adding impurities doping into the crystal structures, its conducting characteristics can be changed in beneficial ways. A semiconductor junction is formed when two distinct doped areas occur in the same crystal. Diodes, transistors, and most contemporary electronics are built on the behavior of charge carriers such as electrons, ions, and electron holes as these junctions. And the silicon, germanium, gallium arsenide and elements along the periodic tables, so-called metalloid staircase, are examples of semiconductors. Gallium arsenide is the second most common semiconductor after silicon, and it is used in laser diodes, solar cells, microwave frequency integrated circuits and other applications. Silicon is a crucial component in the production of most electrical circuits. And the next slide is about a PN junction. Inside a semiconductor, a PN junction is an interface or a border between two semiconductor material types, namely the P type and the N type. The semiconductor's P side or positive side has an excess of holes, whereas the N side or negative side has an excess of electrons. The doping process is used to produce a PN junction in a semiconductor. And the next slide is formation of a PN junction. When we utilize various semiconductors materials to form a PN junction, there will be a grain boundary that will prevent electrons from moving from one side to the other by scattering electrons and holes, which is why we employ the doping procedure. For example, consider a P-type silicon semiconductor sheet that is very thin. A portion of the P-type silicon will be changed to N-type silicon if a tiny quantity of pentavalent impurity is added. This sheet will not have both a P-type and an N-type area as well as a junction between the two. Diffusion and drift are the two sorts of processes that occurs following the creation of a PN junction. As we all know, the concentration of holes and electrons on the two sides of a junction differs, with holes from the P side diffusion to the N side and electrons from the N side diffusing to the P side. This causes a diffusing current to flow across a connection. Here below we are having the PN junction formation. There's a green color diagram, and the next part will describe about the same this diagram of a PN junction. When an electron diffuses from the N side to the P side, it leaves an ionized donor on this N side, which is stationary on the N side of the junction. A layer of positive charge develops as the process progresses. When a hole is moved from the P side to the N side, an ionized acceptor is left behind on the P side, causing a layer of negative charges to develop on the P side of the junction. The depletion area is defined as a region of positive and negative charge on each side of the junction. An electric field direction from a positive charge to a negative charge is generated due to this positive space charge area on each side of the junction. An electron on the P side of the junction travels to the N side of the junction due to the electric field. The drift is the name given to this motion. We can observe that the drift currents in the opposition direction as a diffusion current. And the next slide is about biasing conditions for the PN junction diode. In a PN junction diode, there are two type operational regions. One is P type and next one is N type. The voltage applied determines one of three biasing conditions for PN junction diodes. First one is there is no external voltage provided to the PN junction diode while uh, is at zero bias. Next one is forward bias. The P type is linked to the positive terminal of the voltage potential, while the N type is connected to the negative terminal. Is called as a forward bias. Reversed bias is the P type is linked to the negative terminal of the voltage potential, while the N type is connected to the positive terminal. It is called as a reverse bias. And we can see briefly with diagram about the forward bias. The PN junction is said to be forward bias when the P type is connected to the positive terminal of the battery and the N type to the negative terminal. The built-in electric field at the PN junction and the applied electric field are in opposition direction when the PN junction is forward bias, and the resulting electric field is smaller than the built-in electric field when both electric fields are added together. As a result, the depletion area becomes less resistant and thinner. When the applied voltage is high, the resistance of the depletion zone becomes insignificant. At 0.6 volts, the resistance of the depletion area in silicon becomes absolutely insignificant, allowing the current through the battery. For this is the diagram below is mentioned. Below diagram is for forward bias. And the next slide is about a reverse bias. The PN junction is said to be reverse biased when the P type is linked to the negative terminal of the battery and N type is attached to the positive side. The applied electric field and the built-in electric field are both in the same direction in this situation. The resultant electric field in the same direction as a built-in electric field, resulting in a more resistive, thicker depletion zone. If the applied voltage is depletion area gets more electrons. The below diagram is indicated the reverse bias diagram. And the next one is PN junction formula. The PN junction formula, which is based on the built-in potential differences generated by the electric field, is as follows. E naught equal to VTI to the N into ND minus NA by NI the square close bracket, where the zero bias junction voltage is E naught. At room temperature, VT is the thermal voltage of 26 MV. The impurity concentrations are denoted by the letter ND and NA. The intrinsic concentration is denoted by Ni. And the next one is a flow of current in PN junction diode. When the voltage is increased, electrons move from the N side to the P side of the junction. The migration of holes from the P side to the N side of the junction occurs in a similar manner as the voltage rises. As a result, a concentration gradient exists between the terminal on both sides. There will be a movement of charge carriers from higher concentration region to lower concentration regions as a result of the development of the concentration gradient. The current flow in the circuit is caused by the movement of charge carriers inside the PN junction. And the next slide is about VA characteristics of a PN junction diode. This is a graph denoting the PN junction and the flow of currents, which is a reverse forward region and breakdown voltage, forward voltages and reverse region. And it is described in this paragraph. A curve between the voltage and current across the circuit defines VA properties of PN junction diodes. The x-axis represents voltage while the y-axis represents current. The VA characteristics curves of the PN junction diode is shown in the graph above. With the help of the curve, we can see that the diode works as different in the three different areas, which are zero bias, forward bias and reverse bias. There is no external voltage provided to the PN junction diode. While it is at zero bias, which implies a potential barrier at the junction prevents current passage. When the PN junction diode is in forwarding bias, the P-type is linked to the positive terminal of the external voltage, while the N-type is connected to the negative terminal. The potential barrier is reduced when the diode is placed in the fashion. When the voltage is 7 volt for the silicon diodes and 0.3 volt for germanium diodes, the potential barriers fall and current flows. And the next one is the current grows slowly while the diode is under forwarding bias, and the curve formed is non-linear as the voltage supplied to the diode overcomes a potential barrier. Once the diode has crossed a potential barrier, it functions normally and the curve rises quickly as external voltage rises, yielding a linear curve. When the PN junction diode is under negative bias, the P-type is linked to the negative terminal of the external voltage, while the N-type is connected to the positive terminal. As a result, the potential barrier becomes higher because minority carriers are present at the junction. Reverse saturation current occurs at first. When the applied voltage is raised, the kinetic energy, and that means Ke of the minority charge, increases, affecting the majority charges. And this is the point at which the diode fails. Diode may be destroyed as a result of this. And the next one is application of PN junction diode where it is applied. When the PN junction diode's arrangement is reverse bias, a diode may be utilized as a photodiode since it is sensitive to high. It has a potential to be utilized as a solar cell. The diode can be utilized in LED lighting applications when it is forward biased. Many electric circuits utilizes it as a rectifier, while varactors employ it as a voltage controlled oscillator. And the next slide is about advantages of a PN junction diode. No filament is necessary for this. Occupies lesser space. Long life. It is a much smaller. It needs only smaller PD to operate in radio receiver. It is cheaper. It requires no time to warm up to produce a current carrier since it is a semiconductor. It can be operated with low voltage sources. It is strong and not easily destroyed. The next one disadvantage of a PN junction diode is it is a non-ohm conductor. Second one, when polarized, only very small current flows. And the next one is, what is data science? Data science is nothing but it is an interdisciplinary field that uses scientific methods, process, algorithms and systems to extract knowledge and insights from noisy, structured and unstructured data and apply knowledge and actionable insights from data across a broad range of applications. And the next one is PN junction in data science. The role of PN junction in data science. Data diodes and unidirectional gateways work by preventing return communications at the physical layer, typically over a single fiber optic connection, that is fiber strand. The transmit does not possesses transmit capability. This provides absolute physical layer security at the cost of bidirectional does not exist. Data diodes are true air gaps, albeit is only one direction. And at last, finally, thank you for watching my CLT presentation.